Hello, my name is Dr. Jeff Aberle, and in this video we're going to cover superpulse technology. So in my prior video, I covered the continuous wave technology, which is the type of laser that you probably have if you already own a laser. But in the previous video, I went over the inner workings of continuous wave technology, and in this video, I'm going to use this generic wave to demonstrate what superpulse technology is, superpulse lasers. So what I'm going to do is I'm going to hide everything except for this generic wave down here. And what I want you to notice, what I've done here, we still have time along the bottom. So, from here to here is 1 second, and power is on the left. So here would be 0, and in this case, this would be 250, which is right here. I'll show you how that comes in. But what I've done with this laser, this hypothetical laser, is I have fixed the output to 0.5 watts. So this laser cannot deliver on average any more than a half a watt. And I didn't just pick this at random. This happens to be the cutoff between class 3B and class 4 lasers. So anything above 0.5 watts is considered class 4. And so this would still be considered eye safe. And so that's why I chose this number. Now what I've done here with this laser is I'm only able to change two different values on this: pulse duration and frequency. So let's take a look at this, because this is very different than the continuous wave. So here, if I have a frequency of 1, all I have is this really quick impulse here at the very beginning, and then nothing for the rest of the second. In fact, this impulse is so narrow, it's only 0.002 seconds or 2 milliseconds long or wide in time. And then the rest of it is off. But what I want you to do is look at the equation here. So the equation, my average power here is 0.5. This number's fixed. Okay, this will not change in anything I do here. And the 250 is determined by these other two values here, which I can change. So I can change the frequency and I can change the pulse width. So if I have a 2 millisecond pulse and only 1 pulse per second, I can actually have a 250 watt laser in this machine that kicks out an impulse of 250 watts. So I get 250 watts worth of depth, but I'm still only averaging a half watt output. That's pretty neat. The 250 watt laser I have to have in there, but it only has to provide that for 0.002 seconds. So that's easier to do than a continuous wave laser that's 250 watts, which you would never see. You're never going to see a continuous wave laser at 250 watts. It'd just be way too hot. But so 0.5 watts is average. But I want you to notice what I can do here. So if I double the frequency, so in other words, I'll have 2 pulses. If I double this, I have to half this. So I'm going to take this, and I'm just going to take this from 1 up here to 2. And you'll notice that I now have 2 pulses per second, so 2 hertz. But now my power level, my peak power level, had to come down from 250 to 125. And the watts here and the joules per second, these are interchangeable terms. I went over this a little bit in the continuous wave laser, but watts is the same thing as joules per second. And joules per second is the same thing as watts. So I labeled them like this for that purpose, just so I could say that, so you get a little more comfortable with this terminology. So anyway, 2 hertz, this joules per second, this time, I can get still my 0.5 watts average output. So this is still eye safe, even though I'm putting out 125 watt impulses. And so I get a lot more depth this way than with a continuous wave laser. Okay, now let's just say we take it to 4. Now I had to cut this again in half because I went from 2 to 4. And so this got doubled again, and this got halved again. But what we haven't played with is the time here, the pulse duration. So what I'm going to do is I'm going to set this back to 1 hertz. And what I'm going to do is I'm going to drop the pulse duration down to something ridiculous. I'm going to take it all the way down to 0.000002. So this is 2 microseconds. Now I want you to notice here, first of all, sorry about that. If I zoom in here, you can actually see this is a pulse. See that pulse right there? And actually, I'll stay zoomed in there. Watch when I play with the pulse duration. I can actually narrow that. Isn't that neat? And if I zoom in, I can really get in here close for this crazy, ridiculously low pulse duration of 2 microseconds. But but it's only on for, for that short period of time, but yet I can have a laser now that is 250,000 watts. So I can get 250,000 watts worth of depth if I only have that laser on for 2 microseconds, which is 0.000002 seconds. And I can zoom out here. It gets ridiculous because this is just so high, but this is legit. You can actually do this. This is the trick of physics that I was referring to in the first video. So you see there's the top. You can barely see anything here in the bottom until I zoom in again. So let's now play with the hertz. Let's just say I take this from 1 hertz to 2, which you'll notice is the 250,000 gets cut in half down to 125. So I'll change this to 2, and voila. We now have 2 pulses. Now they only have to be 125,000 watt pulses now, so I can have a less powerful laser. And if the pulse durations are still that narrow, which they are, very narrow, it will still average only 0.5 watts. So let's just take this down, and I'm going to drop this all the way down to, I'm going to take the frequency all the way up to 1,000. So if I go frequency 1,000 pulses per second at a duration of 2 microseconds, which is what that number is, I can now have a laser that's 250 watts. So I get 250 watts worth of depth, but yet I'm still averaging only 0.5 watts. And with today's lenses that are used on human beings and animals, you don't even feel 0.5 watts because it's spread out so much on the lens that you apply to the skin. So it's spread out, so you don't even feel this. So this is like, I don't want to say it's heatless, but you don't notice it. Maybe some type of equipment would notice 0.5 watts, but you can dissipate this just fine. And so you don't really notice this. But yet you're still getting 250 watts worth of depth. And that's the trick of physics. That is a trick of physics that continuous wave lasers cannot do. And continuous wave lasers cannot be modified to do this either, because their lasers are limited to what the output powers that they have. In the prior example, it was 15, 15, and 15. But with this hypothetical, I can make this whatever I want. And but the pulse durations have to be very, very low, very fast. And so when you start getting into these quick pulse durations, you're getting into the limits of what laser diodes can do. So that kind of wraps up the generic waveform, and I'll use this now to demonstrate some of the super pulse lasers that are out there that you can actually buy and use, and they're very fun. So I'll be right back.